So one of the nice things of Django is it can do some of this work for us. We kind of saw when I was showing examples of cookies from real websites that they were using cookies to like track information about a session. And a session is a loose word for like a user interacting with a website over a consistent period of time. And the right way to think about this is when you log on to do banking, you do it for a while and then you stop, or when you go to browse Amazon, you do it for a while and then you stop. So you might, if you leave for like an hour and then you come back to Amazon, Amazon might decide, all right, that's a new session for this user. But so there's a lot of legitimate reasons why companies want to be able to know about it and pay attention to user sessions. One of the things that Django does for us is it has what's called session middleware. And we haven't talked too much about what middleware is. And the right metaphor here is if you think of a series of pipes and the HTTP request comes into the Django server. And before it even gets to the code that we write, it goes through other Django code. For example, the raw data of the HTTP request has to be turned into an instance of the request class, into a Python object. For stuff with the CSRF token, Django needs to do things there. And that's, we saw, to use an example, like being able to, well, I deleted it, but to print a cookie, like if we were doing that here, we didn't write the code that takes the data and constructs this object that we can then interact with. Django does that for us. And so middleware is all the different pieces, all the different parts of the pipe that an HTTP request flows through. And as you can see, authentication is like your classic middleware use case. And so is having a session. And Django may be using cookies for this, in fact, and we'll see. And a lot of this middleware is just configured by default. And you can add other custom middleware, or you could get rid of things if you wanted. And what we want to do with the session is just a simple page counter, right? To see how many times we've counted the page. And at the moment, I have a typo. So let's start by getting rid of that and getting rid of that and getting back to basics and seeing if that works. And right now, this is pretty boring because I have hard-coded this information. I modified our template just a bit during the break. As you all can see, it's very simple. I'm still using the index view. And I think you all could sort of see how we could use a cookie to bring this to life. We could have a cookie with like a count property and we increment it each time back and forth. And the good news is that Django will do a lot of this for us. And let me show what that looks like. Because that session middleware is configured by default with Django, our request object has, that's probably, another object that has its own methods. It might be another dictionary type thing named session. And what we're going to do is if a session, a lot like a cookie, it's just a dictionary under the hood. And we're going to create a property here named count. And if it doesn't exist, we're going to create it. And if it does exist, we're going to increment it. And now instead of this being hard-coded, we're going to grab it from this request session object, and fingers crossed, this should work. There we go. So now we are using Django's built-in session middleware, and let's see what this is doing under the hood. If we look at this request, in fact, let's just go ahead and look at cookies. And now we have a whole bunch of interesting cookies that Django has created for us. Now, these two are from before. So in fact, I'm just going to clear everything. And now if I refresh the page, we've been here once. And note that Django created a session ID cookie. We don't have to do this work. Django is doing this for us. We don't even have to care right now where Django stores the session ID. It could be storing it in SQLite. We could probably configure it to store it in Postgres. It might be storing it in memory. But now we've got sessions, which is great. And it lets us do other things as well quite easily. So great question about local storage. There's two pieces here. Where is the browser storing the session ID cookie? Browser local storage is some part of the memory that the browser has access to that it gives JavaScript running in the browser limited access to. Somewhere else in all the memory that the browser has for stuff is where it stores cookie information. So those are sort of separate containers. However, well, actually, I take that back. Django sessions does not necessarily have to be stored anywhere because that is the whole point of a cookie. So I got a little bit ahead of myself. What we're going to see a bit later with sessions is that you can connect a session to stuff that's stored in the database. Right now, the whole point well, no, Django is actually doing that. I apologize. I got a little confused because if we look at this session ID cookie, this doesn't have any information about count, right? And if we look at this, we can even tell it's not a hash because it stays the same. So the cookie is named session ID. Django, which is not running in the browser, right? This is our backend server application, so it can't be in local storage. Somewhere Django does have to store this dictionary that's associated with that ID, and we can add a print statement here. Let's see what this looks like when we do this. It's a session store object. So surprisingly, we get this is a Django object printout, right? And it would be interesting. We could look up this object and see all the different properties. But like one common way that Django could be doing this is just imagine that Django in the Postgres database that Django has for its own use that it creates has created a row in a table somewhere to store session information that's connected to a session ID. And that's where this stuff is persisted. But it can't be in local storage because it's not happening client side in the browser. This is happening in our server side application. And we can add more information as well. Like we can add some start time. I'm copying this from the guide code from the lesson, which is, I certainly don't know this by memory. Let's see, undefined variable date time, string.
Get the import date time.
Yeah, that might help. Let's see if this does it. we'll just see. We'll try this out and see what it looks like when we run it. And I think I want to pass that in here. And we will have to update our index, or our template rather. And we will see in a moment if I have any typos. So I got something not quite right here. Start time. And I think I will just add a print statement here. And we can see what it looks like, and we can go from there. So I do see a printout of a date. If someone sees what I have wrong here, that would be helpful. I think I'm probably doing something. Sorry?
It may be your import statement. I think it's from datetime, import datetime. But I might have to look it up real quick.
Say that again, Francisco.
I think it's from datetime, import datetime.
Let's see how we do there. I might do a quick Google. I think you're on the right path. Let's try, I see. Let's see if that does it. No, I'm getting a little.
Can we just print out the what datetime.datetime.now is outputting?
Yeah,
or
I
returning?
have a print line here. It's printing out none at the
Well,
moment.
you're printing out the session.get right now. It's
I
probably
see.
a problem with how you're setting the cookie, not the problem with the datetime import.
That's a good point.
It's
Yeah,
just
and if
to
I
narrow
can't,
it down.
that's a good call. And if I can't get this working in a minute, we'll just move on, because to be honest, it's not critical. I think datetime now, print datetime now. Let's see what we have here. So you're right, because we're getting the date here. So let's see what we have. And yeah, I'm doing something wrong with the request session. That has to be relatively simple, because we're not doing anything that complicated at the moment. And I think I'll just move on if I can't get this one working.
Is it even entering that first if not block?
It should enter it once, and it must, because otherwise count would never have been working. Which is a good thought.
Well,
and I wonder if
yeah,
this
but
needs
you're
to
in the
go.
browser, you're already up to count like 17 or whatever, right? So you'd have to clear the cookies to force it into that block.
Oh,
You see what I'm saying? Like,
yeah. Let's see. I'm gonna. Oh, it'll be a good teaching moment. Object of type datetime is not JSON serializable. So that's actually progress. I think you may have found the issue here. Yeah, that talk about, yeah, thank you so much. So this is, as frustrating as that was, this is a great teaching moment, and one of the challenges with really like working with the browser and the server is a client-server architecture, and that's a distributed application. And especially now that we've got application state happening kind of in two places with cookies, it starts to get trickier. And thank you so much for pointing that out. The problem was the cookie was already set with the count, and I had the code to like set the start time inside here, and it was never getting there. And I just had this myopia on, I must have been doing something wrong with this code because I haven't been writing a ton of Python recently. And I totally missed that. The program was actually doing what it was supposed to. I just had the wrong assumption about how things were happening. And when we add this start time feature, by the way, it also makes more sense to use this to mark the beginning of our session. And that change also would have produced like a more useful error message, or I think some information for us quicker. And that's how sort of like refactoring is kind of related to debugging, and that a lot of the times, like once you figure out the bug and the problem, sometimes that also indicates a way you can redesign a bit of your program to make it harder for that kind of mistake to occur. So thank you for being patient with me on that journey there. And now we have a start time, an account happening, and request session, and Django is storing session information wherever it wants to, maybe in SQLite, maybe in Postgres, and it's all being tracked by this session ID cookie that's getting passed back and forth between the client and the server, the browser, and our Django web server on every HTTP request. How are people feeling about this, and what are people's thoughts and questions?
It's fairly simple. It's kind of like implementing any other object into Django, get, save, all that.
Yeah, exactly. And that's where, you know, these batteries included frameworks like Django have their challenges, but one of the pluses is they do have a lot of this set up for you. Like all the work of sessions and session cookies and all that is taken care of by the Django session middleware. I know we're at time. I do want to go on maybe 10 minutes more so I can show a basic sign up and login flow. How do people feel about that? Thumbs up. Okay, awesome. And thank you in advance for sticking around a bit longer, and let's do it. So we are going to need a model for this one. We're going to need a user, and I'm going to make a very simple user. And we'll see soon. Django gives us some built-in user classes that we can use and inherit from. But for the moment, we're going to write our own. And it's going to be very simple. There's going to be a username. The usernames do have to be unique. And there's going to be a password. And I'm going to talk more about this password field momentarily. And we're going to make the length of the password longer. And the password does not have to be unique. So we wouldn't want to store an actual password in the database. Like if my username, you know, if this was my password, we would not want to store that in Postgres ever. And the reason is, what if someone malicious somehow got access to Postgres? It could be an employee. There are all these stories out there about tech company employees not being very good about handling sensitive data, right? Like you wouldn't want a software engineer at Amazon to be able to look into the database, find someone's username and password, and see all the stuff they bought. For all sorts of reasons, that'd be a really bad idea. There's also the possibility of someone malicious gaining access. It might not even be through a flaw in our web application if the database is used by other programs as well. So general best practices is you never ever store plain text, is the term, passwords in a database. And instead, what you want to do is hash them. A hash is a function it's not quite like encryption. It's sort of one-way encryption. Every time you give it an input, it returns a different output. So an example might be ABC123 gets turned into, I just made this up. But the important thing here is, let's have this, I'll make up, we have a hashing function. But the important thing here is that this is consistent. Because now we can look stuff up, right? And this is sort of the basic idea of a hash table or a hash map. Instead of, let me go ahead and copy this. And we can get rid of settings PY. Whoa. What did I say here? XVV32F. This is what we store in the database, the hashed password. And if we want to make our hash even a little more secure, and I'm sort of making this up a little bit as I go. Assault is a constant, some sort of string, and in reality, it's going to be a bunch of characters, and you add it to the password because the salt is something you keep secret. It never has to be sent to the browser. We can just apply it to the password, and so that adds sort of an extra level of security to our hash. And this lets us look up a user. And let me go ahead and write a sign-in method, and I think that will help illustrate some of this. We probably can't write an actual template, but we might have time to use Postman or something to just send an HTTP request with this. And after this, I'll pause and we can take questions because I know I kind of went through a bunch of things. I probably need to import JSON. So this is a route for a user to sign up, right? And in the request body is going to be some information like a password. And there would also need to be a username. And now let's see what we do with this. And let's yeah, I'll just use let's say salt equals I think I have this right. I need to double check, but I'm pretty sure we need our salt to be consistent. Otherwise, it makes it hard to know how to apply the hash. And if I'm getting this wrong, someone please let me know, but I think we're on the right path. And this is where we're going to use a third-party hashing library that is applying an algorithm, SHA-256, that's commonly used for hashing stuff. And we're not going to worry too much about what's going on there and how it generates the hash. And that is the kind of thing you want to leave to third parties. Oh, Diz, thank you. It is generated per password. Yeah, and I think the salt must be stored somewhere as well. If I have that right. And this is not code that we all would have to implement. Django has helpers to do a lot of this for us. I do want to walk through a bit of this process. And let's see, convert our string to bytes, then display the hashes. Yeah. Let's not worry too much about this at the moment. I will come back to that. This is the more interesting part. And give me a moment and let me make sure that I do have this hashing code relatively correct. Oh, thank you. That totally does matter about the salt. That was from my old version. And let me do a couple imports that we need here. And I will, in fact, and we should probably write our generate salt function. And again, Django is going to do all this work for us. We're not going to have to do this manually. And in fact, I'm going to do a little bit of renaming and cleaning up here. And to show kind of so I will figure out what's going on there in a moment, but I just kind of want to walk through the logic of what's happening here and this basic idea of hashing, that we have a password. We use a third-party library to hash it, right? To turn it from ABC123 into XVVV32F. To make this process more secure, we add what's called a salt, which is a random string. And I was wrong, we generate this per password. And this makes it even harder if someone was going to try to, like, if someone did get access to this hash and wanted to work backwards to figure out the password, that's going to be even more difficult to do. And then when we save this to the database, the way we have it set up here, we do need the salt and the hash password together. This is a bit lower level than it needs to be, really. And you all won't have to worry about implementing this, but it's good to see. And just to close the loop, let me show what logging in looks like. And then we can talk about this code a bit and answer questions and break for lunch. And in fact, I'm just going to copy this code from over here because it is exactly the same. When a user logs in, they're going to have a username and password. And as you are all familiar with, we would then go to the database to find our record for that user by their username. And now we have to check the password. And let me talk about what this code is doing in just one moment. Give me one sec here. This should really be renamed. Okay, so and we're going to also import JSON response so that this code is more or less correct. Thank you for bearing with me there. To sort of walk through what happens, a request comes in to log in. We grab the username and the password. We go to the database. We get information about that user. And this is the part you will not have to implement manually. However, it is good to have some understanding of what's happening under the hood in terms of how things are hashed. The short version is we only have the hashed password in the database and the salt. And we grab both those things. We run that same hashing function with the real password, and we see if they match. Right? Does hash ABC123 equal XXVFF? And if they match, we know that that's a correct password. And if not, it's a wrong password, and we just tell them that the login failed. I know I jumped through a lot of stuff here, so I want to check in and see which parts it would be useful to go over again and what questions people have. And any question is fair game. So please fire away.
I had a question about the salt.
Yeah.
So is the salt different for every single like every single password you put in or any like information? Is it always going to be different salts for every single information?
It is different. I got that wrong initially, and I missed who pointed that out, but thank you. The idea is you generate a new random string every time that, and I believe, let me fix my code here real quick. Yeah, you generate a new random string every time we're creating a new user account. That random string is our salt. Let's say for the raw password, let's use my example of ABC123. We put them together. Right, so here the example would be And in some ways, it's probably easier. I should just write def hash password. This is really an easier way to read this. Because now over here, this just can be this can just look like this. And this is dramatically easier to read. We combine these two things together. And then when we save this to the database, we also save the salt. And they're separated by this $sign here. I'm going to make this a colon because I think it's even easier to read. So you always create a new salt for each new user account, but you do have to save that salt because otherwise it would, I think, be impossible to actually check a password when it comes in. Which is what happens over here. When you log in, we get the user information from the database, which has the hash password and the unique salt for that user, and we have to separate them. And here, now that I've written this hash function, I can just do it like this. I'm not sure why it's prompting me for named arguments, which I think is a lot easier to read, to be honest, and sort of gets rid of a part of it. And we make that comparison. Does that help a bit?
Yeah, that helps. Is there a point to hash the salt at all, or is that like just pointless?
It's pointless. It's a good question. There is no point. The value of the salt is that it's a randomly generated string. As long as our random string generation code is random enough, which is its own separate topic of how a computer, without going into it too much, computers have something called entropy. They look at like how often keystrokes are pressed and like things they can use to generate like random data. And then when you want a computer to generate a random string, it like uses that random stuff to generate it. It's interesting to read about, but a bit of a rabbit hole. Point being, the point of the salt is we want it to be random. And as long as it's random, that's the security that it adds. Yeah, that's a really good question. Again, I want to mention again that you will not have to be implementing like salts and hashing logic all the time and stuff. And yes, the salt and pepper is exactly the kind of metaphor. Really, it's nice to know, and it's good to be able to talk about in an interview how this stuff is saved to the database. And the major takeaway is that we never want to store a plain text password. And what we'll see is that Django, when we use Django's built-in user model, and in fact, let me just quickly do a bit of a preview of their docs on that. Django does this work for us, which is great. Let's see which one of these has what we want. Here we go. So it might not be exactly like this, but the good news is this authenticate function does all that work of salting and hashing and worrying about all of those things that I was just walking through. And we really just have to use this. And it comes from this Django contrib auth library. And if we go into settings PY, lo and behold, Django contrib auth middleware, authentication middleware. Django is already configured to set up to do a lot of this stuff for us. And that's one of the nice things about using things like Django. And there's a whole bunch more to all of this. But by doing this and by using Django's user object and creating a user, it will handle safely storing password information. I think, yeah, right here, there is a set password method. And if we looked into the Django documentation on it, at some point it would start talking about salting and hashing and things like that. And it is probably using this same SHA-256 hashing function. I don't keep up with like the most current one, but for a long time, this was sort of the standard one that everyone was using. So the most important thing is feeling comfortable with the flow and kind of seeing how this connects to the Django sessions that we looked at a little bit earlier. What else is on people's minds? And what other questions do people have, whether it's about salting and hashing or logging in? Really anything with things that we've covered. Okay, folks, thank you so much. Thank you for sticking around a bit. I know this one ran long. I will push this code now and get the videos up there. The exercise for today is really focused on cookies. The main exercise is implementing that view counter that we looked about. And there are some stretch assignments as well that I may remove those because I think wherever they went, they're not there anymore. So I would say if you're interested in forging ahead, and I'll throw this into the Slack now, I would forge ahead onto tomorrow's lesson and tomorrow's exercises where you will use Django authentication to actually have some user accounts with like some basic things like a to-do list and stuff like that. So I'll update the GitHub so that this is the stretch assignment. And have a great lunch, everyone, and happy coding, and thank you. All right, I'll catch everyone later.